This video is all about this lathe. Not everything about it, I'm not professional. But it's gear driven. I had another video, I put another video up before I knew anything about this, and I know a little bit more about it now, obviously because I've took it apart, cleaned it up and put it back together again. It's got a little bit of a squeak, I can't seem to get rid of that. I've just dropped a little bit of oil inside there. It's got no oil holes for the bracket here, so that's probably where some of the squeaking's come from. But yeah, it's all about this. I've had a little bit of a play already, because this is what it's for watchmaking, for making the recesses and facing off watch parts. This is obviously got to have a part on it. I did have a part on it, but the super glue is not strong enough. I used super glue to glue it onto this, and as I was turning it, it flicked off. So I thought, you know what, I'm just going to play on the back plate itself. But yeah, it's surprisingly easy. So I'm going to rig it up and then do a little bit of a video of me turning some of this by hand. Surprisingly easy until you start to go the wrong way. I'm trying to be fancy now and going that way. It's not working. My grinding isn't fantastic. It works alright for going that way, but not that way. That's the tool tip. Just a circular piece, it's cut. Oh, come on, focus, god damn you. Focus. It's ground just slightly below centre. And also ground at that front edge to give a little bit of a clearance, and then a rake on clearance on the end. So obviously when it's the cutting tip touches first before the actual back of it, so the full front edge isn't touching like that. It's got a little bit of a clearance on the back of it. It's not a fantastic grind, it was just a quick go, just so I can have a play. You can see that it's raising up a little bit of a burr on the edge of the actual cut. You know what I mean? Just there, right on the edge, it's raising a little bit of a burr. So my grinding could be improved. Not could be. It should be. It should be improved. But yeah, it's takes a bit of practice. Right, this is a spindle. This is machined all as one piece. There's no joins that I can see anywhere. There's various shoulders around the place, but I'll look closer to it, at it should I say. And there's no shoulders like this section here being push fitted onto it. It all looks like it's all one piece, apart from this pin obviously. I'll explain that in a little bit when I've got a pin in there. You've got an L shape there, and the way I think it is, I think it's obviously hollow. It's a lot wide. The bore inside here is a lot wider than the bore for the pin. So I think it's machined from this end, drilled through, and then made wider for the spring and the gubbins in here. Now this gear as well at the back, I think that's all as one piece, and it's been machined with a shaper. Because the join, where it transitions from the actual gear to the shaft, it looks like it's beveled just inside there, and this bevel seems to run, well, the root of the gear seems to run level with that bevel, and then bevel up to this outer diameter. So I think that gear is actually part of this, and it's been cut with a shaper for the teeth. And to get the pin in there and the spring, because there's a spring in there, they would have put it through this back end, and then about 99% sure press fitted this dead centre into it. The thread on that, I've got no clue whatsoever what that thread is. It's incredibly fine. I thought initially that was just a pin, just a push fit pin, but no, it has got a thread on it. Now I need to modify that, because that pin is a little bit too long. I need to make some kind of bushing to fit between this and the top, so it doesn't flop about. You'll see what I mean in a minute. If I can manage to find that hole again for that screw into. That was amazing. I won't be able to do that again if I tried. That's it. That's what I mean by there's too much play. And I think, to be honest, that would have been a replacement pin done by somebody else, because I can't see the manufacturer leaving that kind of slop. That's just ridiculous. But you see the pin at the end, it retracts in, and then the pin itself turns into that cutaway at the side. So when it's pulled back, it stays back. And I think the whole idea is, I'd love to be able to take it apart to clean it out properly. I think the whole idea is you're supposed to push that out, and the spring is supposed to push it to its full extent, but it doesn't. You've got to pull it manually, because there's a lot of crap in there that I can't get to. But I'll leave it like that for now. The faceplate. That's the faceplate for it. These jaws could benefit with being keyed a little bit, because they spin round. But you undo the back and it opens them up, and then you adjust it to this small dial, or wheel should I say. You open that up, and then when you tighten it, it gives that little bit of adjustment there. So whatever you're gripping onto, you'll set that for the right height, so when you grip it, it doesn't as opposed to it being pinching at the front and not the back, or the back and not the front, if you get what I mean. So you'll set that so it's gripping at the actual thickness of the material that it's gripping. The precision in this is incredible. That tip is tapered, and it's a perfect taper, and that perfect taper. So when they're pushed together, the tapers just meet up. The internal taper and the external taper just meet up flush, just as the actual back plate meets. Sorry, the faceplate meets the register at the back. The one thing that they did mess up with is the hole pattern. The 3-hole pattern is slightly out. Not by much. It's a lot better than I'd be able to do. So you've got to rotate it to get the closest match. Put in, which I'll do off camera. Right, now how the spindle fits in. It's got the dead centre, obviously, and it's got an internal convex bore or dip in the shaft. So it's a little bit finicky to get it set right. So I mean, it's like machining in this, to say this is from about very early 1700s to about mid 1800s. It's incredible. Now, these are parallel pliers. Still got some slack in it because it needs the top. The top is also the same, it's machined. Now it's a total oil, the oil that's used is a total loss system, there's no way to keep it in there. Now you might not be able to see, but it's not whether it's wear or machined specifically for this purpose, so it's not actually full contact, but it has got an air gap, and there's going to be a certain point where it contacts, where the steel contacts the bronze. Now it has got a little bit of slot there. I think originally this recess here, shoulder should I say, pushes up against the front, but as this is pushing this way, there's a slight, something like 1/4 play. So if I have it set so it's pushing the spindle into the taper, there's a very slight gap at the back. Now with full lathe, you're going to need some kind of thrust bearing, but with this it's very light work, so it's very light work that it's going to be doing. So that should be fine. It's got 2 taper pins. It's on the right way around. Yeah, that's the right way around. This is going to come off at some point, to put a little bit of oil in it anyway. That fits on, and then we've got 4 screws that I'll put in a minute. And that wrong way mark, you always go the wrong way. That rattling is that brass plate or bronze plate. It's got a very nice smooth action. There's no noise on the actual gear itself. The rubbing that you hear, I've got to put a little bit of oil in it. This is just dry. Where the shaft goes through there and there, it rubs. There's a little bit of oil there. So once I put oil in, there should be virtually no noise at all. And once I sort that out so there's no rattle. Just there. So I'll put the screws in and come back to you. Onto the cross slide and top slide. And this is how it fits onto the bed. The bed will also go through there. That's a nice slip fit. Not too tight, not too loose. This brass plate that goes through is obviously for two bolts there that look like they've got holes for Tommy bars for adjustment. So when that's on, you get your Tommy bars underneath. Which way is it going to be? Yeah, it's going to be that way. So the headstock's this side. You get the Tommy bars, undo them, and you can angle this which way you want to align it so it's horizontal to the actual plate itself. The dovetail is in a few pieces, it's not machined out of one. It's like that. You just got the male, would it be called? I suppose the male dovetail that's approximately that length. Now, why they decided to do it this way, I don't know, because it's a hell of a lot of machining. But the thread for this lead screw goes all the way through the full length, not just how we do it or how machines are manufactured these days where the thread is only a certain section of it. It's more like you've got an insert, a threaded insert in there, so you can replace the insert rather than the full dovetail. But this, it must have took them a long time to do it. That dovetail, the whole length of it, like I say, all the way through is bored at 36 TPI. I'll come to that TPI as well in a minute. 1/4 inch 36. That must have took an absolute age without the proper machine tools that we use these days. These dovetails are obviously steel and they're separate. Now that's fixed. This one's fixed. And then this one is adjustable. See these 3 screws here? What you'll do is you'll undo these 2 screws here and then adjust the grip. You adjust the fit by tightening these screws here until pinch the actual internal dovetail. And then you'll tighten these back up again. Obviously with a little bit of care, because you loosen these off, tighten those up, get that right fit, and then as soon as you tighten these two up, it locks the dovetail. So it's a little bit finicky, but it's the way they did it instead of having a separate grip strip. That looks like it's been homemade, put in by somebody else. It's a travel limiter, so you can adjust for how wide you want the bore to be, or the width that you need to be. You just undo these 2 here. That's good design as well. It's got a split there, look, so it's so you can tighten it up. Just undo those 2, just adjust how much you want the travel to be, and you just tighten it back up again. Quite shaky hands, so there's no movement there now. But yeah, that looks like it might be homemade rather than actually part of it. Moving on to the top, obviously that's the dovetail for the top slide. Now the way that the screw is captive, the screw itself, you'll be able to see it rotating. Look, it's got a shoulder on it. Now that's not a separate piece that's screwed to it. That is part of the lead screw. So that would have been one entire length, then machined down for the actual thread, filed down. But that section of the screw fits into a recess, but there's a gap. It's designed to have a gap there, so you can adjust the backlash, but also over time when it wears, you've got a little bit more place, so you can tighten the screws up a little bit more and adjust the backlash that way. There's very little backlash, to be honest, on that screw, but you'd expect that for the full length thread. Now, while I put these screws in, I'll explain something. I was thinking about modifying this and sticking a dial on here, so I could get precise measurements. It was just a thought. I more than likely wouldn't have done it because it's a lot of work to do, and really it wasn't original. It's probably on that way around. That's probably why it's not going in. Now, there's two reasons why I'm not going to do that. One, it's modifying a machine to have something that it didn't originally have. It's a lot of work. That's two reasons already. But the third one is that it's 36 TPI. So if you was to stick a dial on there, the dial would be useless. Reason being. Right, because this is a 36 TPI screw, same as the top slide, it's a little bit awkward to divide if you were going to be doing any type of divisions. So if you do decide to make a machine, just thinking about the TPI that you want to use, because 1 inch divided by 36 TPI, or so one whole rotation of that screw will give you 0.0277 recurring inch of travel. Now, if you were to put a 100 division dial on that screw, you get an incredibly fine adjustment, but the adjustment is obviously hundredths of that, so that is going to be very hard to figure out for mathematics. Do you know what I mean? If you're creeping up to an external dimension or internal, but it's a lot of maths to work out for the actual travel that you want that dial to move. Now, if they upped it to 40 TPI, it's 0.025 inch of travel per rotation. Divide that by 100, obviously it gives you that. Now, if it was 10 TPI, a much coarser thread, each rotation would obviously be 1/10 of an inch. And for 100 divisions, that would give you 1/1000th of an inch movement of travel, you know what I mean, on the cross slide or top slide for each division of that dial. Now, I'm a metric man, I'm used to metric, so anything that I've made in the past that I wanted to put a dial on, I've always had it as M61, or with the metric taps and dials, there's a lot of different sizes for the 1mm pitch. There's, as far as I know anyway, there's M6, there's M10, M11, M14, M16, you know what I mean? All these different sizes have that 1mm pitch, which is handy because if you want to put a dial in it that's got 100 divisions, that will then give you a 100th of a millimetre movement for each division, which is easily enough resolution for what this noggin wants. I can't be dealing with 1/1000th of a millimetre, that's just ridiculous. But 1/10 of a millimetre, sort of 100th of a millimetre, is on par with 1/1000th of an inch. Maybe, I don't know. Not sure, I haven't got a calculator in front of me. Now on to the top slide. I think I mentioned it before, same again, this is exactly the same thread size and pitch as the cross slide. I love that, I love the design of that wheel, it's gorgeous. Same design of entrapment as well, entrapment of the lead screw with a shoulder, so you've got fine adjustment there. That if I remember right, this is broached, square broached. So the need, can't figure out the need, I suppose, yeah, to keep it on so it doesn't come off. But that's broached, square broached. Same again with the dovetails. Now they've gone through the detail of some, like I didn't mention it, the faceplate, the jaws, all three of the clamps have got little dots knocked into them, or imprints. So like here, look, you've got a 1 there, if you can see it. Got 1 there, 2, 3, and then no marks. So obviously, if you've matched up those, then the only one remaining is going to be there. The screw heads as well have got dots on them, stamps. So you've got 1 there, 2, 3, and then nothing on that one. That's an incredible attempt at precision. You know what I mean? So when someone's putting something together, they know that, or taking something apart for maintenance, putting it back together, they know that that particular screw went there, that one went there, and on the actual brass plate as well, on the bottom side, there's those dots as well, so you know which orientation, because obviously, because that's flat, that's flat, it can go on either rotation. So whoever's putting this together knows that that is the orientation that these dovetail blocks go on. Same deal as the cross slide, you've got the adjustable ribs there, so it just pushes that rib in or out depending on where you want it to be. Now this is great design, I love this. This screw here, that's very tight. I'll tighten that up a little bit too much. That's it. Right, this screw pushes and pulls these 2 pins in and out. Those pins are tapered. Not all the way. I don't know if I've got this upside down for you, I'm sorry if I have. But those are 30-degree tapers. And on the actual block that goes in, it's got a tapered bottom. And the idea of that is it adjusts the height of the tool. Drop that in there, and the tapers match up. It is a very tight fit. And then the top that goes, it's got a top here that goes on. So when you put the tool in, I did bring a rough round tool. Can't figure out where I put it. Put this in for now. When you tighten that up, puts pressure on the actual tool and the tool block underneath it. And if you need to adjust the height, you'll just loosen that. It's better if I put the screws in. I'll put the screws in and come back to you. Right, back to it now that I've put that top on. Yeah, so I'll flick it that way around. Yeah, like that. So you'll stick your scriber in it. Got to loosen that off now. This is very professional. I think you'll get it by now, looking at my videos. If you want professional, mine isn't the video to look at. Or videos. Right, yeah, so these pins, if you want to raise that tool, you'll loosen this off, push that in, or turn that in, and those tapers push this block at the bottom up. And then once it's to the height that you want, it's very hard to, looking at this mobile screen looking down, so I don't know if this is upside down or not for you. Hopefully it's not. So I'll have to record all this again. But yeah, you get a gist anyway. You'll adjust these pins in and out, and then you tighten that or loosen it to get the actual tool to the right height. And I'm half thinking about making a square one, flat top one for square tooling. Although, another thought I've had in my mind, if you get a square HSS tool bit, turn it 45 degrees, what you have to do is just put on the top of it, half the thickness away at the top, and you'll have like a diamond shape. So you have, if you imagine, like that, like that, cut, oh my days, cut 45 degrees across, that'd be the cutting, that'd be the bottom, so the relief, that'd be the top, and then the top would be ground away. That's a Tommy bar adjustment as well, so you loosen that, you can get a rotation. It's not for taper turning that, because obviously you're turning the block, the tool, this will still be going wherever the dovetail tells it to go. But yeah, I'll put that together. Now, same again, that block is threaded all the way through, the full length of it, which is ridiculous. I can sit over here all day. 36 TPI. So that's 72 half turns to get to move an inch. Right, this is where you figure out that after you've screwed all this lot on, this is where you figure out it's not in alignment. So you've got to take it all off again to be able to adjust that dovetail block, screw it all back on again. Yeah, so that's the top of the cross slide. Tailstock, same deal as before, that brass plate inside for the screw. Now I've got a missing screw on this one, but it doesn't matter because the screw itself is a very weird thread. It's I think the old record hand planes had that thread for the frog adjustment, but trying to find a tap and die for that thread is incredibly hard. So the very rare time that I'll use an actual tailstock, I'll just take the thumb screw off the bottom of the cross slide or hand tool rest unit. It's the same thread. So I think that's what I'll do. Same as the top. It's a bit of a weird thread. I do plan on making one anyway. I can get the tap for that die, should I say, but I'll have to make a form tool then to make the gripper screw that's on the top of there. Look. So I will get to that, and that might be a little video, but I think click spring. If you go to click spring and look in, much better tutorials than what I can do. This isn't actually fastened in. There's a pin. There's a pin at the top there. Look. You can just manage to see. That's our key. There's a matching hole just there, and that literally just pushes in. Nice thing, that's not going to secure it, but it does. You can see the pin going out, back in, and this isn't unwinding. Now, this isn't the type of lathe to do drilling on the lathe. You won't be drilling with this type of lathe. But the only issue that you'd have arise from that, for it not being actually fixed to the body, is if you're drilling, because you go to turn it in, you get resistance from the actual drill itself, and then this would start to push out. Or if you're using a live centre with quite a bit of force, but you're not going to be using a live centre with a lot of force with this. I doubt very much with this lathe that I'll actually use this tailstock, but who knows, sometime in the future I will. That is some kind of cutter. Now the skill in the filing work on this is amazing. And you've got one on the hand turning rest as well. So if you take this screw out, I thought originally this was going to be a spring in here, but it's not. I'm not going to have to do this without tearing fingernails, splitting fingernails. Ah, there we go. That's the cutter, and that looks to be all filed. Very. These things. That's incredible work. The idea of that is that as well with the filing on that to get to match up, pretty much match up on the other side as well. That was screwed in to keep it in place, but it was screwed in loose. And I'll just pilfer the screw off the top. The screw here. This is a screw that I need to make for this. You'll put the tailstock in, the quill should have said. And then when you tighten that down, it pushes that cutter down onto the actual quill, so it just doesn't rotate at all. Loosen it off, rotates. So it's a way to grip the quill without damaging the quill. Incredible, incredible work. There's a little thing for you in the comments. Guess how many times I say incredible in this series of vids. The hand turning rest, much the same deal as the other one. You've got the cotter there. That is a very tight fit. Here's where everything gets knocked off the table. That is a very tight fit in there. It's better to be tight than loose, that's what I say. And that has got a double plate. So you've got the standard plate there that raises for the bed, but you've also got another one there for the actual rest, for the actual adjustment for the rest. The way that works is obviously the bed's through there. As the pressure's put on to lock this to the bed, it also puts pressure on the plate at the top to lock this. So to adjust that, you just loosen that and just pull that out and then just tighten it back up again. I think that's about it, all covered. So I put the lathe together and then get you another angle.